Alright, so in this video, I'm going to talk about phase change diagram worksheet, or so-called phase diagram worksheet. I will actually separate into two worksheet, right, for the same page one. Only because like one part I will talk about the solid, liquid, and gas, and then the 6 phase change, the triangle thing. Another one will be I will repeat on solid, liquid, and gas, and then I will talk about the critical point and the triple point and then the normal temperature. Okay, so first of all, the phase diagram here is that we want to make sure that the x-axis is temperature in degrees Celsius, and the y-axis is always pressure in atmosphere. And we changing temperature, we are going to change our state of the matter, so we're going to measure the pressure. So the phase diagram is always like a Y shape. Now, even though the graph could be a little curving, but it's generally a Y shape. So the first thing we're going to note that is the solid is always on here. The liquid is always on the right hand side. And then the gas is always down here. Okay. So then now the equilibrium is, I'm not going to repeat the notes here, but the equilibrium is always the boundary between the two states. Okay, the boundary. So for example, this boundary must be between solid and liquid. So this is my A, right? It's here, ABC, because this is between solid and liquid. So in other words, actually, remember we said that when we have a situation, we have solid and liquid, that will be only when you have melting. So that means on this whole line is actually melting phase change. Okay, the phase change is melting because melting has the solid and liquid at the same time. Okay, so then the between liquid and gas will be B. Okay, right here, right? This boundary is between liquid and gas. So the phase change that has liquid and gas is actually the vaporization. Okay, this is all called vaporization, or in this case is actually the boiling. Okay, because we increase the temperature ourselves, so it's not quite just like vaporization, it's actually boiling. From here to here is boiling, from here to here is melting, and then this section is the C part. Okay, so it's the solid and the gas phase, solid and gas phase. Okay, so I would say that actually this is not just melting, because a solid to liquid will be melting, but if a liquid to solid will be freezing. So here, this line is actually both melting and freezing. And right here is actually both the condensation and the boiling. Okay, so I'm going to talk about first the sublimation, right? So the sublimation is actually, right, start with the S, right? So the S. So sublimation is actually solid to gas. Okay, so for example, dry ice, melt to gas, it's carbon dioxide. Deposition is gas to solid, and condensation is the gas to liquid. Freezing is gonna be liquid to solid, and then vaporization is liquid to gas, and then melting is solid to liquid. All right, so then now I'm going to put down this 6 state. Okay, so the SDC FEM. Okay, the S here does not stand for solid, the S here stands for sublimation. So we want to say that the sublimation is between from solid to gas. So from solid to gas, which is here. Okay, so this is sublimation. Okay, and then deposition is from gas to solid. So from gas back to solid, this is deposition. Okay, and then condensation is gas to liquid. So gas to liquid. I'm sorry, gas to liquid should be condensation. So let me just get write out. So it's actually, this is wrong. Okay, just give me a second, please. Okay, so should be gas to liquid will be condensation, and then from liquid to solid will be freezing. So liquid to solid will be freezing. And then from liquid to gas is vaporization. Liquid to gas, vaporization. Right? And then finally, melting is solid to liquid. So actually, if you compare this to the physical change, the triangle, it looks like a quite triangle. I just did not draw it. You know, if I bend this line here, it will be like a triangle. But this is how the 6 phase comes from. Okay, so I'm going to stop here. This is the first one. Okay, now if I go to the second, like we're going to mark this again. Okay, so if I mark this again, we want to label, all right, this is the solid, this is the liquid, and this is the gas. Okay, so we want to find out what's the normal. Now the normal is actually when you have 1.00 atm. Okay, 1.00 atm. So if you let me see, if you use a pencil, okay, I got a pencil. So if you, right, so draw a dot line horizontally from the 1.00 atm, go all the way to the curve. You keep going. Okay, something like that. Okay, I did not draw really good, but I can actually make it a little better. Just give me a second. So usually I will use a ruler, but actually I don't have a ruler with me. So you want to draw a little better. So something like that. Okay. Okay. So 1.00 is the normal meaning in phase diagram. So 1.00 atm is normal. So now, since we say that, right, we say that this curve is between freezing and melting. Freezing and melting. And then here, you want to see that this line, dot line, you're passing through the first spot. Okay, right here. Right here. So we say that this is happening freezing. This is also melting, because from the first worksheet, we say that this line have both freezing and melting happen at the same time. So actually this line is freezing and melting. That means this point will be normal melting point, also normal freezing point. Okay? Because this line is freezing and melting at the same time. All right, solid to liquid, liquid to gas, melting and freezing. So this point equal to normal melting point, also equal to normal melting point, freezing point. So if you draw the dot line, go all the way down, okay, you will find the temperature. Normal melting point equals to normal freezing point, which is about 100 degrees Celsius. okay, which is about 100 degrees Celsius. Okay, so normal melting point, normal boiling point, normal freezing point. And the normal melting point and normal freezing point should be the same. Should be the same. Okay, because this line is actually freezing and melting at the same time. Okay, now on the other hand, this dotted line at 1.06 atm also passing through here. So remember we say that this line, it happened on condensation. It also happened on vaporization. Okay, but since we provide heat here, so this kind of vaporization is actually particularly referred to boiling. Okay, in this question we did not ask about condensation, but if they ask, hey, what's the normal condensation point, should be the same thing as normal boiling point, because in this case vaporization is the same thing as boiling, because we provide heat, we provide energy. So if you see that the 1.00 dot line come up to here, right, and then you put dot 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 on the bottom, right, so this point is normal freezing, normal boiling point, I'm sorry, normal boiling point. Now if someone asks you, hey, is it the same thing as normal condensation point? Yes, it is, because this line is the condensation and the boiling. So this normal boiling point is about 350 degrees. Okay, now what is a triple point? Triple point is the temperature and the pressure where three states coexist. So in this case, which point is three states coexist will be this one right here, because I can have solid, liquid, and gas happening at the same time. So it's the fog area. Okay, so I'm gonna point it out. This is the triple point. Okay, it's right here, the fog area. Okay, so if you draw the dot 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 line, go down to find the pressure, and you want to also draw the dot 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 line. Let's see. I did not draw really well, but you see that the first one, okay, this one, okay, the thicker one, okay, the thicker one. So the triple point is at the fork. Then what about the temperature? The temperature is about 90 degrees. Okay, so the temperature at the triple point is about 90 degrees Celsius. And then the pressure is about 0.60 atm. Something like that. Okay. Now here, keep in mind that even though you give me a approximate number, that's fine. As long as you can label exactly where is the triple point, where's the normal melting, where's the normal freezing, they're the same thing, and where's the normal boiling. That's good enough. So triple point is right here where the fog area. And then if you go down and go left, you will find the temperature and pressure. And finally, the critical point. Now, critical point, the CR, is the temperature and pressure, no matter how much temperature you gave, that's the point only gas start to form. Only gas, no matter what temperature you have. So since then, okay, since after that point, beyond that point will be only gas. So this is actually the critical point right here, the last point of the line. All right, so if you bring that pressure, bring that dot 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 down, okay, right, this point, and then if you make that horizontally, okay. All right, so the last point of the graph is a critical point. So the pressure and the temperature will be that critical point. So the temperature critical temperature is about, I guess it's 800 degrees Celsius, and then the critical pressure is about maybe 1.55 atm. Okay, 1.5 atm. Now again, the temperature and pressure value, if I give you a question, would be very specific. As long as you understand that this is very simple to label. If you separate like this way, is the critical point is the fork area, critical point is the last point, and then when the 110 cell passing the first line, that point is normal melting, same as normal freezing, and then when it passes the second time will be normal boiling. Okay.